Hello everyone, this is Alec Cromer, and thank you for watching my video regarding my Astronomy 1102 Star Distance Calculator. I'll go ahead and refresh my page real quick. One of the things I wanted to do is I wanted to take a star's right ascension, declination, and distance, and I wanted to be able to compare it with another star given those same values, and then calculate the distance between those two stars. The first thing I did was I wanted to find a good database. I decided to choose the HYG database. It features stars from the Hipparcos, Yale Bright Star, and the Gliese star catalogs. Now, the reason I chose this is because I've seen some catalogs where it features many more stars in this. This one only features about 120,000 different stars, which is a lot more manageable than a lot of the star lists that have 500,000 and 2 million stars. Then what I did was I took the comma-separated value of this star list, I brought it into Java, and I was able to send it as SQL into a database right here. This makes it great for sorting and great for pulling up specific columns that if you want to search for. So for example, if anybody wants to find a star where the right ascension is greater than 14 and less than 15, so like you get an average value of like 14.5 and you're not quite sure, and if you have a declination, in this case greater than 15 and less than 16, you're able to do some simple queries and you're able to pull up all those stars, and you can look at something like its visual magnitude, or you have a proper name in case you wanted to find the actual star if it's something that's more popular. And back to the actual website itself, up at the top here we have an area where you can enter in two proper named stars. This includes names like Calf, Alpheratz, Sol for our own sun. A lot of these I don't know, Betelgeuse, Canopus. This is for stars that are, stars that you've heard about and know about. So if we want to take, say, Almach, and we wanted to find the distance between Almach and, say, Polaris, we go ahead and enter these two values up into star 1 name and star 2 name, and we press submit. It pulls in the two stars right here at the top with their tables and respective values, and we were able to determine that Almach and Polaris are approximately 330 light years apart, or 102.3 parsecs. And we do this by taking the distance, the right ascension, and declination of each star. Then we convert the star's distance to light years from parsecs. Then I convert the right ascension decimal form to degrees. Then we calculate the coordinates of star 1 and star 2. And we do the rectangular coordinate difference, and we're able to get the distance in light years. One of the things you might notice is up here at the top we have XYZ values. These are the coordinates themselves, which are already data that comes from the HYG database, but I wanted to make it a little bit more technical and find these values using the right ascension, declination, and distance. Another feature I have on the website is we're able to look at all the stars. I have a nice little text here that says, "Trust me, you don't," because I have separated it into 20,000 increments. So up in the top right here, you can see a little search bar or scroll bar that's getting progressively smaller as more and more data is being filled in. A lot of these stars do not have proper names. They just have coordinates and right ascension, declination, and we see B9 for the spectral types of these stars. If we go back, you can actually search here. But if we go back, we have another section that allows you to find two specific values for the star, or for each star that you're wanting to identify. So if we have, say, we have a declination for a star, we can just go ahead and populate that, and we have the star's distance. Let's say we don't quite know the right ascension. I'm not sure how you know the declination but not the right ascension, but we'll go ahead and enter these values in. I believe it was declination. I actually do not remember. I just copied and pasted it. So this is Si. I don't know if that's how you pronounce it, but we'll roll with it. The next star we'll choose, I don't want to choose Polaris again because I've already done that. We'll do NK. Let's say we have, we look up on the internet and we find this right ascension of NK, and we find the declination as well. And so we We don't know the distance between these two stars, but we're about to find out. Right ascension and declination. I believe these are the I believe this is the distance for the first star, but we'll go ahead and check it. As you can see, we have Si, right ascension at 0.945, which we've now figured out. And the distance between these two stars is approximately 574 light years, or 177.94 parsecs. Up here at the top, we also have another list of information. So these are all the values that show up in the table that came with the HYG database, such as the star's apparent visual magnitude, spectral type, Flamsteed number as a distinct value, the radial velocity in kilometers a second where it's known. It'll be null if it is not known. And then I believe that's everything. If you want to check out the code itself, I featured it on my GitHub. The code's not too shabby. It's pretty readable, I would assume. I didn't do much in terms of marking down what each area does, but I like to think that it's at least decently readable from a standard coding perspective. And if you have any questions, go ahead and ask me up. Thank you.